We're at the cusp of a longevity revolution. Biology has become an engineering project. Just like computer programs have ones and zeros, the human body has a code too. It's made up of the A, C, T, and G of DNA. And scientists are learning how to reverse engineer that. Things like tissue engineering, gene therapy, and other types of personalized medicine that are going to allow people to live longer and healthier lives. There's only ever been one person in the world who's ever been cured of AIDS, and that's Timothy Brown. And he was cured because he got a bone marrow transplant from somebody who had a genetic mutation that doesn't allow AIDS to proliferate in the body. And so researchers are now working on how they can create that genetic tweak in other people who have AIDS so that they can cure AIDS. Gene therapy for the last decade has had trouble because it wasn't easy to do before. Researchers have made a lot of progress in making it safer and easier to do. Dr. Carl June at the University of Pennsylvania has been working on making the tweaks to T cells to try to cure AIDS. He actually just had a really exciting announcement recently where he used gene therapy to cure leukemia. What he did was he took out some of the immune cells from the cancer patients, tweaked them, the T cells, he tweaked them so that they would notice cancer as an infection. Because the problem with cancer is that your body doesn't realize it's a foreign invader because it's part of your system and it doesn't attack it. And so what Dr. June did was he tweaked the immune cells of these patients so that they would notice the cancer, then took them out, and he did that in the lab. Then he re-injected them into the patients, and the patients got huge fevers and reacted essentially as if they had a big infection. And after a couple of weeks, all of their cancer was gone because their immune systems had fought it off. And so that's one example of how scientists might be able to recode our systems to fight off diseases. Sometimes it can take a long time to go from the lab to widespread use in society. For instance, tissue engineering is already here. I mean, scientists have the ability to grow brand new human organs like tracheas and bladders and blood vessels in the lab. It can be done with your own adult stem cells. It's not in widespread use right now. And how long will that take? You know, that's up to the regulators, and not only that, but training doctors to learn how to use these techniques. And so it does actually take a long time. There are so many advances going on right now in biotechnology that are really have a wow factor, right? Like gene therapy to cure cancer, and tissue engineering, growing brand new tracheas in the lab, also to cure cancer or to cure damage from infections. I mean, all these things that are going on, and you see them once in the newspaper, and you read it, and you say, ah, that's great, and then you forget about it. But if you look around and you take all of those stories and you put them together, as I did in one big chapter, you can see a real clear picture of how the future is going to change.